All right, we're still on 8.1, defining and using sequences and series. This is video 3. So here we're going to start actually talking about series, and we're going to we're going to write series using what's called summation notation. So let's give that a try here, but first, actually, let's go over some vocabulary. So we've talked about sequences, that was in the first 2 videos, but now we're dealing with series. And that is when the terms of a sequence are all added together. Okay, and then I said we're going to write these series in summation notation. So we need to talk about what that is. It can also be called sigma notation. So you might hear it either way. It is the shorthand notation for the sum of the terms that follow a pattern. And you'll see that here in just a minute. But first let's do the core concepts of series and summation notation. Okay, so a finite series, remember if it was a sequence we listed 2, 4, 6, 8. That was a sequence. Series adds them up. Okay, so it's finite, which means it has an end if it just stops at the last term. It's infinite if it has dots at the end. Okay, just like with sequences, except now instead of commas in between there is a plus sign. Now if we want to use summation notation to write a series, what we do is, sorry, I'm jumping ahead. What we do is we take however many terms are in that series, okay, that number is on top, 1 is on bottom. Or if we're starting, say, if n is 0, and that's what we're starting with, then I would say I or n, just depends what variable is used in the rule. In this case it has I, so it's I equals, it could be n, it could be k, it doesn't matter. But if I'm starting with that number being 0, then I would have I equals 0. And then if it's going to term 4, then it would have 4. And you would find all of these terms from I being that number being plugged in. So here we have 2, 4, 6, 8. Now this starts with term 1, ends on term 4. 1, 2, 3, 4. There's 4 terms. Okay? This is the rule for those 4 terms. So that's how we're writing it. Okay? And these mean the same thing. If I were to write it all out, it equals this summation notation. And the reason it can be called sigma notation is that is a sigma. Okay? Infinite series is the same thing, except it has an infinity symbol on the top because it just keeps going forever. Okay? So let's actually talk what this talks about, in case you're totally confused. Alright, so like we did in the last video, we're going to have to find a rule that this fits into. And then we're going to write the function, or I'm sorry, the series using summation notation. So we need to figure out what's happening each term, okay? Well, let's see. Looks to me like I add 25, I add 25. I'm assuming that pattern keeps going. So this is a linear equation. All right, which means I know it's arithmetic because it's adding the same number each time. And then, so I know, let's see, let's draw our little sigma notation here, or sigma symbol. If I say I'm going to start on the first term, and we can use I, you can use n, it doesn't matter. In the last video we used n, so on this first problem I'll just use n. N equals 1. That's small and below here, but I'm writing in a big marker so it doesn't show that. But I go to term when an is 250, so I'm not quite sure how far I go yet, so I'm not going to fill this in yet. But I know I'm going to take 25 times n, and I would have to add or subtract something to get my first term if it wasn't already this. Because remember, if my table, like we were drawing before, if the table helps you, 1, 2, 3, 25, 50, 75, ... Okay, and I know I end at 250. So I need to figure out what term this is. So if I take whatever n is and I'm multiplying it by 25, this is where I got it. It's what it's being added each time. Okay? Well, I get 25, and that 1 times 25 is 25. So I don't need to add or subtract anything to this to get that first term. The 25n is my rule. But I need to figure out how far I'm actually going. Well, 25 times what gives me 250? 25 times 10. Okay, so I know I'm going from the first term all the way to the 10th term. Okay, so let's try it again with number 7. All right, let's write our table just to help things out here. I have 1, 2, 3, 4 terms. Wow, okay, that's a line in the 4 there. That I just made a really big 4. Sorry about that. And then it just keeps going. All right, so right there with my, if I'm writing my summation notation over here, I know it's going on forever, so I know I have infinity on top. And this time, just because it's going to use other variables, I'm going to use the variable I. And I'm going to start at the first term. Okay. This one was 1/2, 2/3, 3/4, 4/5. And we need to see what's happening here to write our rule. Well, I see some patterns here. If I look at the number on top, whatever n is 1. That's what's on top. 2's on top, 3's on top, 4's on top. Okay? Remember, these numbers on top are n. Or in this case, I'm going to use I. So just change these to I. Okay? So that means I know I have a fraction, and I is going to be on top, because whatever that is what number was on top. Then I look at the bottom number. Well, it's 2, 3, 4, 5. So it's counting up by ones. So 1 times whatever n is, okay, or I here. But it's bigger than that. It looks to me like to get to my first term, it can't just be I, because then it'd be a 1, but it's 2. So it's I have to add a 1 to it. 1 plus 1 is 2. 2 plus 1 is 3. 3 plus 1 is 4. 4 plus 1 is 5. So I get the I plus 1. Whatever that number is on top, plus 1 is what gave me the number on the bottom. That I number, what's in the top of my table, is the number on the top of each fraction in the numerators. So that this was my rule, but to write it as, you know, what the actual sum is in summation notation, it would be all of this. We start at the first term, so we see I equals 1 to infinity, and we put that on top and below our sigma notation, and then we write our rule. Okay? So let's just give that a try. And again, to find those rules, it's just looking for patterns. All right, so do numbers 1, 32, 33, 36, and 38, and then move on to the last video.